When we want to talk about volume of a figure, the units that we're going to consider are cubic units. In class we saw how to find the surface area of a cube, but in this case we're going to find the volume of a cube whose side is 1 centimeter each side. So if I complete the net of this cube, I will have a cubic centimeter, which is going to be the unit to consider when we talk about volume. So this one would be a cubic centimeter. Now if I start stacking one after the other, I will have a volume, in this case for example, of 4 cubic centimeters. Basically, to find the volume of a figure, I have to, in the case of prisms, I have to consider the area of the base and multiply times height. So for example, here we can see that after stacking 10 cubic centimeters on top of each other, we will have a volume which is taking into consideration the area of the base, which is in this case 1 square centimeter times 10, which is the height. So we will have 10 cubic centimeters. In this case, I'll make a more complex figure, but still it'll be a prism. In this case, the base is going to be 4 square centimeters times the height. It'll be 4 times 10, 40 cubic centimeters. If I continue stacking 10 of these together, I will have 10 times 10. So here in this case I will have 100 cubic centimeters. This figure, for example, has the area of the base is 100 square centimeters times the height 4. So I will have a volume of 400 cubic centimeters. That means that in this case I have 400 of these cubic centimeters stacked one on top of the other, etc., until I complete the 400. Okay? So if we talk about prisms, remember in class we completed some prisms and we made the nets of some prisms. So to consider the volume of a prism, we're going to consider the area of the base. In this case, since this is a triangular prism, the base is a triangle. I know the area of this one, and I know the height of this one. So in this case, for example, the volume of this triangular prism would be the area of the base. The area of the base is 10 and 75 hundredths of centimeter times the height. I know the height is, in this case, 5 centimeters. So if I multiply this, I will find 5 times 5, 25, carry 2, 5 times 7, 35 and 2, 37, carry 3, 5 times 0, plus 3, 5 times 1. 2 decimal places. And in this case, the units for volume are cubic centimeters. That is, in other words, the equivalent of stacking 53 of these inside this figure to complete the volume of 53 and 75 hundredths of a cubic centimeter. So in the example of the cube, I know that for the cube, the base, whatever the base is taken into consideration, it's going to be a square. So if I put it this way, the base is a square, or any way I put it, it's going to be a square. So the area of the base is, in this case, 5 times 5, so 25 square centimeters, times the height. The height in this case is, again, 5 centimeters. So if I multiply, I will find that for this specific example that we completed in class, the volume is going to be 5 times 5, 25, carry 2, 125 cubic centimeters. So that's the equivalent of putting together 125 of these cubic centimeters into this figure. So pretty much like a box if I start organizing all the cubes inside, I will get 125 of these ones. One more example is this rectangular prism we also completed in class. So if I put it like this, the base is going to be a square, and this is going to be the height. But if I put it this way, the base is going to be a rectangle. The area of that rectangle is 50 square centimeters because the base, in this case, is 10 times 5 is 50. So I have the area of the base times the height, which is 5. So the area of the base, as you can see here, is 50 centimeters, square centimeters, the area, times the height, 5. So in this case, the volume would be 250 cubic centimeters. So again, as in the previous case of the cube, we're going to have in this case 250 of these cubes, which are cubic centimeters, stacked together. For the cylinders, the base we are going to consider is a circle. A circle. So any circle can be the base of this cylinder. So pretty much it works with the same procedure to find the volume of a prism. Since in this case I have that the two bases that are parallel are circles. So I can find the area of the base. I know how to find the area of a circle. Multiply pi, which is 3.14, times the radius squared, and then I multiply times height. So if we, for example, suppose that the radius of the base, the radius is, for example, 2 centimeters. I can find the area of the base. The area of the base is basically a circle. I'm going to find the area of the circle in this case, which is pi, 3.14, times radius squared. The radius for this specific example is 2 centimeters. So 2 squared is 4. Remember, 2 times 2 is 2 squared. So if I multiply this, the area of the base, which is a circle, is going to be 4 times 4, 16, carry 1, 4 times 1, 4, plus 1, 5, 4 times 3, 12. So 12 and 56 square, 56 hundredths of square centimeters, since it's the area. But now I need to find the volume. So the volume of this cylinder, that is set as an example here, I'm going to suppose that this height is 6 centimeters. So I'm going to multiply now the area of the base, which is 12 and 56 square centimeters, times 6, which is the height. And the result is going to be in cubic centimeters, since we are talking about volume. So if we multiply, we can consider the decimal places. 6 times 6, 36, carry 3. 6 times 5, 30 and 3, 33, we carry 3. 6 times 2, 12 and 3, 15, carry 1. 6 times 1, 6, and 1, 7. Now here we have to consider these two decimal places. So let's put them here. And basically for this cylinder, we're going to put together 75 of this and 36 hundredths of this, which is a cubic centimeter. And in class we also completed the net of this cubic centimeter. But remember, in this case we're talking about volume. So the volume that this cube occupies is 1 cubic centimeter.